This is our fourth lesson on trigonometry, and this one's on the sine law. If you want to see where the sine law comes from, you can go to page 470 in your workbook. Notice that you will be given the sine law on tests and quizzes, so you don't need to memorize it. And of course, here's the sine law here. There's two forms there. One is with the side lengths on top that we'd use for finding side lengths. The other one is with the angles on top used for finding angles. At the end of the day, it doesn't matter which one you use. You just save yourself a little bit of work if you choose the right one. Okay, and notice that you need to have an angle side pair to be able to use the sine law. So for example, you need to know angle B and side B. So in the case of example 1, we know angle G and we know side G, so we can use the sine law. Okay, and they want us to find GH, which is of course side J. Okay, so we're just going to use our sine law with the angles on, or sorry, with the side lengths on top. So we'll have J over sine J equals G over sine G. Notice that even though there's 3 parts to the sine law up top there, we only ever use 2 at a time, and it doesn't matter which 2 you use. Okay, so this time it suits our purposes to use J and G, so that's what we're going to use. And we end up, we don't know J. That's going to be over sine of 44 degrees. And that's going to equal 7.8 over the sine of 51 degrees. Okay, and now to get J by itself, we're just going to multiply both sides by sine 44. So J is going to equal 7.8 times sine 44 all over sine 51. And when we punch that into our calculators, we end up with J equals 7.0 centimeters. Okay. Notice it's really simple to find side lengths with the sine law. So we're only going to do one example of those. Finding angles with the sine law, however, is a totally different story. Okay, so when you're finding angles with the sine law, we're going to be solving a trig equation with sine in it, and you're going to end up with 1, 2, or no possible solutions, possible angles, okay? And sometimes you're going to have to look at the math, and other times you're just going to have to look at the situation. So for example, if you're given a diagram, sometimes you're going to be able to see that certain angles aren't possible. Okay, so let's have a look at this guy here. They want us to find angle N to the nearest degree. So we're looking for this angle here. Notice that we don't have side N, so we're not going to be able to do that directly. But if we can figure out angle P, then we can use that and the fact that triangles angles all add up to 180 to figure out what angle N is. Also notice we can use the sine law here because we've got angle M and side M. So we're going to be using M and P. So I'll have sine P over little p equals sine M over little m. So that'll be sine P over 10.0 equals sine 92 degrees all over 11.8. Okay, and same as last time, we're just going to multiply both sides by 10.0 to get sine P by itself. So sine P is going to equal 10.0 sine 92 all over 11.8. And when I get that into my calculator, I'm going to see that sine P equals 0.8469, which means that the sine of my reference angle is going to be the absolute value of 0.8469, which means that my reference angle is approximately 58 degrees. Okay, so with that reference angle, all students take calculus. My reference angle is either going to be here, or my reference angle is going to be here. So, angle P is either going to be 58 degrees, or angle P is going to be 180 minus 58 degrees. That's not a very good 8. Which is 122 degrees. Okay, notice that in this case we can't have 122 degrees, because if I were to try to put 122 degrees here for P, my triangles, I'd already have two angles and add up to more than 180 already. So there's no way my angle P can be 122 degrees. So my angle P must be 58 degrees. Okay, and if angle P is 58, then angle N is going to be 180 minus 92 minus 58, which means angle N has to be 30 degrees. Okay, question 3, we've got triangle EFG. So let's just draw this, just a generic triangle here that we can label up. So angle F is going to be 80 degrees. And what do we have here? EF. Oh, sorry, angle E is 80 degrees. Angle E is 80 degrees. EF is 17 centimeters. And FG is 2 centimeters. And they want us to find angle G. Okay, so notice we've got E, side E and angle E, so we can use the sine law. And we're also going to use G because that's what we're looking for. So we'll have sine G over little g equals sine E over little e. So that gives us sine G over 17 equals the sine of 80 over 2. And again, multiply both sides by 17. I get sine G equals 17 times, 17 times sine 80 degrees all over 2. Punch that into my calculator, I get approximately 8.3709. And I punch that into my calculator and I find out that angle G is an error. We get an error. Okay, so let's have a little bit better look at our situation here and see what's going on. So let's draw this a bit better to scale here. So here's EF is 17 centimeters. And that looks like about 80 degrees there. And it says FG is 2 centimeters long. Notice there's no way we're making a triangle out of that. So that's why you get the error. Okay, so if you're ever working your way through a sine law and you end up with an error like that, first off, go back and double check all your stuff. But if you do end up with an error, it means that there's no triangle possible. Okay, there's nothing we can do to that. There's no way I can flop around that little 2 centimeter stub and have it reach down to point G. It's not going to happen. Okay, so if you get an error, no triangle possible. Okay, and our last guy here, again, let's just draw a generic triangle here that we can label up. There's P, there's Q, there's R. I got 23.5 centimeters, 35 degrees, and 15.3 centimeters. Okay, and they want us to find angle R. Okay, and again we can use the sine law because we have angle P side P. So we get sine R over little r equals sine P over little p. So I get sine R over 23.5 equals sine 35 degrees all over 15.3. Multiply both sides by 23.5. And I get sine R equals 23.5 sine 35 degrees all over 15.3. Nice R. So that means that sine R equals approximately 0.8810. Notice it's standard to use 4 decimal places for this stuff, which means that sine alpha, our reference angle, is going to equal the absolute value of that, which means that alpha is going to equal approximately 62 degrees. Okay, and same as before, all students take calculus. There's a reference angle of 62, and there's a reference angle of 62, which means that angle R is going to equal 62 degrees, or angle R is going to equal 180 minus 62 degrees, which is 118 degrees. Okay, well, let's see. 118 plus 35 is less than 180. So it looks like both of these are going to be possibilities. So let's just scroll down a bit here and see what that's going to look like. So one possibility is going to look something like that, where that's 35 degrees. That's going to be 62 degrees. Or, here, let's see if I can draw this a bit better here. Or, it's going to look kind of like that, where that's going to be 118 degrees, and that's going to be 35 degrees. That's our PQR and PQR. Okay, so notice that both of these triangles are possibilities here. With the information we've been given, we're either going to end up with the angles 35 and 62 on these two corners, or we're going to end up with 35 and 118. So angle R is either going to be 62 degrees or 118 degrees. We don't know which. Both are possible. Alrighty, so example 3 wants us to do triangle PQR. So again, let's just draw a generic PQR here. And they tell us that PQ is 8 centimeters, angle P is 55 degrees, and QR is 12 centimeters. Okay, so the first thing they want us to do is show that only one triangle can be drawn. Okay, so what's going to happen here then is that we're going to get two possible angles from solving our sine equation, and we're going to be able to throw one of them out. So part A, we're going to be looking for angle R to show that there's only one possibility there. So we'll have sine R over little r equals sine P over little p. We get sine R over 8 equals sine 55 over 12 times 8 on both sides. I get sine R equals 8 times sine 55 over 12, which that means that sine R approximately equals 0.5461. which means that our reference angle, sine alpha, equals the absolute value of 0.5461, which means that alpha is approximately 33 degrees. Okay, so let's fire that into our crosshairs here. All students take calculus, which means that there are two possible spots for our reference angles, or for our terminal arm, those reference angles. Okay, which means that R equals 33 degrees, or R equals 180 minus 33 degrees, equals 147. And 147 plus 55 is going to be more than 180. So we've shown that there's only one possibility for angle R, and that's 33 degrees. Okay, and now B asks us to solve the triangle. That means find all of the angles and sides. They want angles to the nearest degree and side lengths to the nearest tenth of a centimeter. Okay, so first thing we can do really quick is figure out angle Q. Q is just going to be 180, 180 minus 55 minus 33. And that's going to give us 92 degrees, so we can put that in. And now we can figure out what side Q is. Little side Q right there. Okay. It's going to be best to use P again because we know that the 55 and 12 are exact because they were given to us. And we're going to have to use the 92 there. But it's better than using the 8 and the 33 as the pair that we know because we know we've got a rounding error on that 33. Okay, so we're going to go Q over sine Q equals P over sine P. Notice I've got the side lengths on top this time because we're looking for a side length. It just makes things a bit easier. So that'll give me Q over sine of 92 equals 12 over the sine of 55. Multiply both sides by sine 92. Throw that into our calculator, and we end up with Q equals 14.6 centimeters. Okay, so notice the important thing here is once you do find your two possible angles by solving that sine equation, you need to see whether or not they actually fit. In some cases, the other angles in the triangle aren't going to let it work. In some cases, it's just going to be the diagram. You're going to be able to look at the diagram and just go, yeah, that's not going to happen. Okay, and time for a hilariously contrived word problem here, where we have some ranger stations that know the exact distance they are away from a fire, but don't know how far apart they are from each other. Doesn't sound very possible. Anyways, let's have a look here. So we've got one fire station, A. So let's see here, and that's reporting some smoke in the direction east, 30 degrees north. So that's going to be in this direction here, going east and then going north 30 degrees from that. And that's going to be 30 kilometers away. And we're going to say the fire is at B. And then we have a second station, C, that's due east of the fire station. So it's going to be somewhere on the x-axis. And it says that the fire is 20 kilometers away. So we've got 20 kilometers between station C and the fire. And now for the amazing part, they don't know the distance between the two stations, even though they have all that information. Okay, so let's see what we know. Right now we know angle A, side A, and the only thing we can figure out is angle C. Side C is our only other piece of information, so the only thing we can figure out is angle C. Okay, so let's start by doing that. And hopefully that'll take us somewhere useful. So we get sine C over C equals sine A over A. So that gives us sine C over 30 equals sine 30 degrees over 20. So we multiply both sides by 30, and that gives us sine C equals approximately, actually exactly, 0.75, which means that sine alpha equals the absolute value of 0.75, which means that alpha equals approximately 49 degrees. So from that, all students take calculus. 49 degrees there, and 49 degrees there, which means that C is going to equal 49 degrees, or C is going to equal 180 minus 49 degrees, which is 131 degrees. So that's going to leave us with two possible scenarios. So if angle C equals 49, we're going to look like that. That's 30, that's going to be 30, that's going to be 20. And that's ABC, which means that angle B is going to equal 180 minus 30 minus 49. So angle B is going to equal 101 degrees. So then we can use, so the distance between the two there will be side B there, so we'll have B over sine B, and we're going to use A because it was given to us, A over sine A. Multiply both sides by sine 101. Throw that into our calculator, and we get B equals approximately 39.3 kilometers. So one possibility is that our two stations are 39.3 kilometers apart. Our other possibility is going to look like this. So that's going to be 30 degrees. That's going to be 131 degrees. And then we can use the fact that they add to 180 to figure out that this is going to be 19 degrees up here. And this time we're going to have B over sine 19 degrees is going to equal 20 over the sine of 30 degrees. Multiply both sides by sine 19 degrees. And in this case, we get that B is going to be 13.0 kilometers. So our other possibility is that that's going to be 13.0 kilometers there. So we have two possibilities for the distance between these two stations. Either they're going to be 39.3 kilometers apart or 13.0 kilometers apart.